Alright, so the question is, um, the points A, B, C, and D given at these coordinates, negative 13, 7, negative 12, 11, etc., will they form a rhombus if we plot them on the coordinate plane? So a rhombus is a quadrilateral of a four-sided figure where all sides are congruent. They're all the same length, and the opposite sides are parallel. So it's kind of a special case of a parallelogram, uh, but where all four sides are congruent. And actually, if these interior angles were 90 degrees, it'd be a square. Um, so a square is a special rhombus. Um, anyway, we're just gonna see if this is a rhombus. So are all four sides congruent, and are the opposite sides parallel? And we'll also check to see if the diagonals bisect each other. If you connect the vertices that are opposite from each other, do they um, do they bisect each other? Meaning, do they split each other into equal halves? Um, so yes, let's do that. So let's just sketch kind of what we think we might have here. We're not going to plot it officially, but just to get a sense of where these points roughly are. And then we'll start doing some calculations to show these things. So point A is at negative 13, 7. So let's call that, I don't know, like there. Let's call that A. Point B is at negative 12, 11. Um, and point C is negative 8, 12, maybe something like that. So we got B, uh, B, C, and then point D, negative 9, 8. Let's just, you know, something like that. So it looks like there could be a rhombus, or it could form a rhombus, but we'll do calculations to show for sure. Um, so the four sides have to be congruent. So for example, A to B, B to C, C to D, and A to D all have to have the same length. So how do we figure that out? Well, this side length A to B, uh, we could figure it out just with the distance formula. The distance from A to B is that side length. Um, how do we figure out that the opposite sides would be parallel? Well, we could find the slope of that line segment from B to C and see if it's the same slope as the line segment from A to D, right? So we can use the slope formula. Uh, how do we know if the diagonals bisect each other? So this is kind of a really tiny diagram. Well, if they share a midpoint, they bisect each other. So we use the midpoint formula. So I've got the distance formula, midpoint formula, and slope formula. They're in a little bit more compact form than you might be used to. I like to do this because it shows me what these things mean, and it's not a bunch of gobbledygook. Instead of x2 minus x1, I just said delta x. Delta means change. So that's a way of saying what's the difference between the x's, which is what you're doing when you subtract one from the other. So the difference in the x coordinates squared plus the difference in the y coordinates squared. Same thing with slope, which I'm calling s here. It's the difference in the y's versus the distance in the x coordinates. The midpoint, usually you see is like x1 plus x2 over 2. That would be the new x coordinate, etc. Well, what is this? You're taking one number, adding it to another, and dividing by 2. You're just finding the average of the two numbers. So the midpoint of 2 points is located at the average of their x coordinates and the average of their y coordinates. So that's what this bar means. So x bar means the mean or the average of x. Y bar means the mean or the average of y. So that's just a little bit about the notation there. So I just wanted to save myself some time from writing all that out, and I think it's just neater this way. Then again, I've also explained it for several minutes, so it's kind of a wash. Alright, so let's jump into it. We want to find the distance from A to B. Let's do that. Distance And I'm just going to say D. This will be my notation for saying I'm calculating the distance from A to B, just to help me keep it straight. So we want to do the square root of the difference in the x values. So here x is negative 13, here x is negative 12. So negative 13 minus negative 12 is negative 1. So negative 13 minus negative 12 is the same as negative 13 plus 12, which is negative 1. And we'll square that. And then the difference in the y, so 7 minus 11 is negative 4. We'll square that. So 1 squared, or negative 1 squared is 1. Negative 4 squared is 16. So altogether we get the square root of 17. And let's just leave it as a radical instead of a decimal. I'm fine with that. Alright, so if we get a square root of 17 for the distance between B and C, and then C and D, and then D and A, then we will have shown that all the sides are congruent. So let's see the distance from B to C. So I'm going to label this little diagram over here so we kind of see more what we're going for. So we just did A to B. Let's find the distance from B to C, points B to C. So that is the square root of the difference in the x's, so negative 12 minus negative 8, so negative 12 plus 8, which is negative 4. We'll square that, just using the distance formula here, and then difference in the y, so 11 minus 12 is negative 1. Well, that's what we just did. Negative 1 squared plus negative 4 squared. It's just the order is reversed. Negative 4 squared plus negative 11 squared, or negative 1 squared. So we know we're going to get the same thing here. Sorry, not 11. Square root is 17. Alright, let's find the distance from C to D. So difference in the x's, so negative 8 minus negative 9 is negative 1, and then we have to square that. Difference in the y's, 12 minus 8 is 4. And you can see again, negative 1 squared, and then negative 4 squared is equivalent, has the same value as 4 squared. It's both 16. So again, we know we're going to get the same thing here. Square root of 17. Alright, and then let's do distance from D to A. Alright, so that's going to be, the difference in the x's, I'll just do A to D, it'll be the same thing. Negative 13 minus negative 9 is negative 4. We square that. And then difference in the y is 1 minus 8, or 7 minus 8 is negative 1. So again, we'll get what we've been getting the whole time. So all that would simplify to the square root of 17. So yes, we do have 4 congruent sides. And that would actually, as a consequence of that, opposite sides would need to be parallel, I believe. But let's prove that the opposite sides are parallel. So the way we can do that is we can find what's the slope of the line that includes B and C, and then that should be the same slope as the line that includes A and D, and then same thing with A and B and C and D. So let's find the slope of the line segment that includes B, or this line segment BC. So the slope of the line that includes 2 points is the difference in the y coordinates over the difference in the x coordinates. So BC, so the difference in the y would be 11 minus 12 is negative 1. Difference in the x, negative 12 minus negative 8 is negative 4. So the slope there, the negatives would cancel out, would be 1 over 4. So 1, 4. So if AD has that same slope, that'll be nice. Let's do that. So AD. So we can look at A and D. The difference in the y's, 7 minus 8 is negative 1. Difference in the x. 7, where are we? Negative 13 minus negative 9, so that's negative 13 plus 9, which would be negative 4, which would simplify to 1/4. Alright, so these two line segments are parallel to each other. Let's check AB and CD. Alright, the difference in the y's. We're looking at AB. Let's switch colors. AB. The difference in y. 7 minus 11 is negative 4. Negative 13 minus negative 12 is negative 13 plus 12, which is negative 1, which is equal to 4, slope of 4. Yeah, just checking. Yeah. Yeah. Just double checking the math. I often forget a sign. I might have done that, but I don't think so. Okay, and then let's do, what was that? That was A to B. So let's check, make sure we get the same slope between C and D. C and D. So the change in y, or the difference in y, is 12 minus 4, or 12 minus 8 is 4. Negative 8 minus negative 9 is negative 8 plus 9, which is 1, which is equal to 4. So yeah, these two are also parallel. Alright, so that's good. And then then let's show that the diagonals bisect each other. At this point, if your four sides are congruent and the opposite sides are parallel, as a consequence of that, the diagonals need to bisect each other, I believe. But let's just show that the diagonals bisect each other using the idea of a midpoint. So here the diagonals are BD and AC. So if we find that the midpoint between B and D is the same as the midpoint between A and C, then they bisect each other. They cut each other in half. So let's do the midpoint of BD. Okay. So the midpoint is just you take the average of the x coordinates, and then the average of the y coordinates. So let's look at B and D. Maybe we'll switch colors. Looking at B and D. So let's take the average of the x's. So negative 12 plus negative 9 is negative 21. And then we divide that by 2, which is negative 10 and a half. So if we average those two, we get negative 10 and a half. Let's average the y's. 11 plus 8 is 19. And divide that in half to average it would be 9 and a half. Okay, maybe I should just write that out. So I'll write it out for B and D. So negative 12 plus negative 9 over 2. That's the average of the x coordinates, and then the average of the y coordinates would be 11 plus 8 over 2. Right. Yeah. So let's check the midpoint between, and I'm calling M the midpoint. A lot of times M stands for slope. Sorry, I wanted to call slope S and midpoint M because that makes more sense to me. So that was BD. If AC has the same midpoint, we are good. So AC. So let's So we take the average of the x values. So we're looking at A and C. So negative 13 plus negative 8 is negative 21 divided by 2 is negative 10.5. Average the y's. We got 17 plus 12 is 19 divided by 2. That's 9.5 as well. So they have the same midpoint, so they bisect each other. So this is a rhombus. Now, and we know it's not, so a square is a special case of a rhombus. We know that this is not a square because the sides are not perpendicular to each other. The one pair of opposite sides has a slope of 1/4, and one pair has a slope of 4. If they were going to form a 90-degree angle, they would have to be perpendicular to each other, and the slopes of perpendicular lines are the negative reciprocal. So it would have to be like 1/4 and -4, or negative 1/4 and 4, something like that. But that's not what we have. So they're not perpendicular, so we know this is not a square. It's just a rhombus. Yeah. All right, we're done.